Today we are studying new topic of semiconductor, that is PN junction. So what do you mean by PN junction? When N type and P type semiconductor or semiconducting material are fused together, the junction form is called as PN junction. That means when P type semiconducting material or N type semiconducting material, they are fused together and there is a one junction, and so this junction is nothing but PN junction. Then next, diffusion. There is a transfer of electron and holes across the PN junction. It is called the diffusion. That means when electron and holes are transferred across this junction, and therefore it is called as diffusion. Then next, when N types and P type semiconducting material are fused together initially, so that in initial condition the P types and N type semiconducting material, there is a presence of electron and holes. So comparatively, first electron in P side and N side, as well as P region and N region. So number of electron in there is a N region is large as compared to number of electron in P region. So there is a electron in N side is greater than electron in P side, only related to part of electrons. And then holes, comparatively to the holes in second diagram. So holes also present in P side as well as P region, and there is a N region, at which the number of holes in P region is large as compared to number of holes in N region. That means we get number of holes in P side is greater than number of holes in the N side. Then next, density gradient in PN junction. So this density gradient is depends upon there is a number of electrons and number of holes also present in there is a PN junction. So in comparatively consider as in P region, so in that P region the density of the carriers in which there is a holes and electrons only. So in that P region there is a density number of holes also present in large as compared to number of electrons in that P region. Therefore density of holes is greater than density of electron in this P region. So therefore in that P region there is a migration of holes will be takes place. So in that P region, that is the density of holes is greater as compared to electron, therefore only migration of holes will be takes place in that P region. And then next consider in there is a N region, and in which N region there is a comparatively number of holes and electron, in which there is a number of electron is large as compared to number of holes. Therefore density of electron in N region is greater than density of holes. Therefore in which there is a migration of electron will be takes place in that N region. So in P region migration of holes will be takes place, and this N region there is a migration of electron will be takes place. So next third is there is a migration of holes and electron in PN junction. So take in first figure, there is a migration of there is a holes. So these holes will be transferred from there is a P region to there is a N region, and then it get transfer from holes P region to there is a N region. And then in second figure, look, there is a transfer of there is a charged particles, that is electron, and this electron that is majority carrier, and they are transferred from there is a N region to there is a P region. So in that time we get the migration of electron from there is a N region to P region or P side of the junction. That means first of all they fill up the holes in P side of material. That means when this electron is transferred from this N region to P region, at that time they fill up the hole in P type material and produce there is a positive ions on the P side. And then next there is a when they are leave behind, it get there is a positive ions, or this positive ions is nothing but there is a donor ions produce in there is a n side. So in n side there is a positive ions will be formed, that means there is a donor ion will be produces. And when in p region, so the migration of the holes from p to n side of the junction, then p region near the junction, and there is a negative charge acceptor ion, that is will be there is a negatively charged ion will be formed, and that is nothing but there is a acceptor ions. So acceptor ions will be formed in there is a p side, and there is a n side will be formed there is a donor ions. And this acceptor ions, that is negative ions, and there is a donor ions, it is positive ions will be formed. Then next, in second, there is a diffusion of charge carriers across the junction. So again the definition of diffusion, that is transfer of electrons and holes across the p-n junction. So this is a p-n junction. In that junction there is a transfer of electrons and transfer of holes from there is a this junction, that means electron from n to p and holes from p to n. So this is called as diffusion. Then next, when the extent up to which the electron and holes can diffuse across the junction, that means this diffusion of the electron and holes is also depends upon the there is a conditions, and that condition is nothing but density of the donor ions and density of acceptor ion. So density of donor ion on there is a n side and density of acceptor ion on p side. Then next there is a subtopic will be formed here.